Hey everyone, welcome back. This is the 8th question in the differential equations chapter of cracking the GRE math subject test. This question is not too difficult. It just requires you to remember a little bit about your hyperbolic functions. But we are given this differential equation and some initial conditions. And then we're just asked to find the function. So I'm going to rewrite the equation over here. We're just told that it's the fourth derivative of y, and I'm going to rewrite it as minus the second derivative of y equals 0. Now this is a linear differential equation. It's not just linear, it's homogeneous. What does that mean? It's linear because this left side here is a linear combination of y and its derivatives. Y doesn't appear here, but its derivatives do. And it's homogeneous because this right side is 0. So we have a general solution for a linear homogeneous differential equation, and all we have to do is find the auxiliary equation. And the auxiliary equation is just a polynomial in some variable m, let's say, with the same exponents as the orders of the derivatives in the original equation, and the same coefficients, which in this case are just 1 and minus 1. So we get m to the fourth minus m squared equals 0. We have to find the roots of this auxiliary equation. So we'll get m squared times m squared minus 1 equals 0. So we get that m is equal to 0, and this is a root of multiplicity 2 because of this square here. That's very important. I'm going to write multiplicity 2. Okay, and then m squared minus 1 gives us two roots, plus 1 and minus 1. Okay, so all our roots are 0, 0, I'm going to write it twice, plus 1, and minus 1. So all our roots are positive, they're real, not complex, no imaginary numbers here. So the general solution is going to be y is equal to c1, some constant, c1, e to the first root is 0, x, that's just 1, and plus c2 x e to the 0 x, because 0 appears twice, the same thing, so it's c1 e to the 0 x plus c2 x e to the 0 x plus c3 e to the 1x, and then plus c4 e to the minus 1 times x, so minus x. Alright, okay, e to the 0x, that's just 1. So we're going to write it like this. And then c3 e to the x, and c4 e to the minus x. Okay, that's our general solution. Now we have to figure out what these constants are, and we're going to use the initial conditions, but first we have to differentiate y. We have to find the first derivative, second derivative, and third derivative, so we can plug in the initial conditions. So y prime, the derivative of c1 is 0, derivative of c2x, that's just going to be c2, derivative of c3x, e to the x, is just going to be c3 e to the x, and the derivative of c4 e to the minus x, well, that's actually going to be minus c4 e to the minus x. Let's take the second derivative. c2 is going to drop out, and we're going to get c3 e to the x, and then minus and minus is going to give us a plus c4 e to the minus x. And the third derivative is going to be c3 e to the x minus c4 e to the minus x. Alright, so let's plug in f of 0 equals 0. So that gives us Okay, that gives us 0 equals, sorry, let's put it here. 0 equals C1 plus C2 times 0 is 0, plus C3 times e to the 0 is 1. So C1 plus C3 plus C4 times e to the 0, that's also 1. So plus C4. Okay. Y prime is 0 equals C2 plus C3 e to the 0, that's just C3, minus C4 e to the 0, that's just C4, minus C4. Y double prime, that's also 0, equals C3 e to the 0, that's just C3, plus C4 e to the minus 0, that's just C4. And y triple prime of 0 equals negative 1, so we have to put in negative 1 here. And then C3 e to the 0, that's just C3, minus C4 e to the 0, that's just C4. Alright, so now we have to figure out what these constants are. From the third equation, we know that C3 is equal to negative C4. That's this one. So C3 and C4, they're just negatives of each other, which tells us that C3, if we look at the fourth equation, C3 minus negative C3, right? So C3 plus C3, that's 2 times C3 is equal to negative 1. So that means that C3 equals negative 1/2, which means that C4 is the negative of that. So that's, sorry, that's supposed to be a 1/2. So C4 has to be positive 1/2. And then if C3 and C4 are opposites of each other, that's just going to be 0, which means that C1 is equal to 0. And then C2, well, we know that C3 minus C4 is negative 1. So that means that C2 is equal to positive 1. Alright, these are our constants. So that means that our function y is equal to C1, which is 0, plus C2, which is 1. So that's going to be x. Just x. And then C3, which is negative 1/2, so minus 1/2 e to the x, plus C4. C4 is 1/2 e to the minus x. So you have to remember that your hyperbolic trig functions, if you rewrite this as minus, and then let's put a little parentheses there, e to the x minus e to the minus x all over 2. Well, that thing in the parentheses, that's just hyperbolic sine, or sinh of x. So our answer is B, x minus sinh x.